So now, last but not least, we have the pleasure to have with us Ms. Jessica Montiel, a highly accomplished and motivated professional with extensive experience in project management, business development, and last-mile operations. So that's very interesting. So she holds a bachelor degree in chemical engineering from the University of Rafael Urdaneta in Venezuela, and a master's degree in international business from Holt International Business School in San Francisco. She worked with top-tier companies such as Johnson & Johnson in the distribution department, and currently she is with Amazon Logistics in the UAE. She's been working as the last mile program lead in Amazon MENA, where she leads strategic initiatives and manages complex projects for Amazon last mile logistics. In her own words, she says, challenges drive her to excellence and diversity keeps her motivated. So now, today, in her talk, she's going to cover how data analysis and developing predictive modeling has helped Amazon and could help any other company in the last mile logistics industry to really increase capacity during a crisis such as a pandemic. So help me welcome Ms. Jessica with a round of applause.
I don't think, yeah. Good morning, everyone. Thank you for having me here with you. Today is a very special day for me, not only because it's my dad's birthday today, but also because I'm here, right? Anyway, I didn't come to talk to you about my dad. I came here with a mission, and my mission is to share with you how Amazon utilizes data to make sure that your packages are delivered to your home, even in times of crisis. So, have any of you, or does any of you have an idea how many packages does Amazon deliver globally in a year? Take a guess. Yeah, that's right. So, Amazon, before the pandemic, would deliver 1.9 billion shipments. After the pandemic, Amazon delivered 4.2 billion shipments. This is a 54% increase in the delivery network of Amazon. Now, how was this achieved, right? Have you wondered? But this is what I'm here for. And before I take you through the journey of how this was achieved, I must take you through the journey of how your packages are delivered. So everything starts with you, okay? You are in front of your computer, you are in Amazon website, you select your product, and then you click checkout. After that, everything you know is that your package will be delivered within 2 days. But what happens in the back end, right? And this is the world of logistics. So logistics is divided into 3 stages: first mile, middle mile, and last mile. So the first mile is the fulfillment center. And this is where Amazon keeps its inventory. And at this moment, we know where the package is going to go and to whom the package belongs to. And this is thanks to an airway bill, which is a label stamped in your package that gives us all this information. Then all these packages are sent to what we call middle mile or source centers, and these are usually co-located facilities to the fulfillment centers. And here what happens is that the packages are segregated by city, by area, or by delivery stations. For example, in Dubai, given that it's such a high-dense city, we have 3 delivery stations to suffice the demand of the city. And then all these packages are sent to what we call the last mile, which is the delivery stations. And this is where the packages are segregated by drivers, and the drivers pick the packages so they can reach to your home. Now I would like to zoom into the last mile, because this is my area of expertise, but also because last mile can become one of the most expensive mile in the logistics if it's not controlled and optimized. So last mile operations has a lot of variables that can influence decisions. Some of those variables are topology, which is the first one that we're going to talk about. And topology as you can see here, is where we understand where the delivery stations should be built. And this is based on the demand of the customers. We do this through a tool called last mile topology. And this is a map of Saudi Arabia. So this is before the pandemic. We would have 10 delivery stations across the city. And then after the pandemic, we increased to 20 delivery stations. Then we have capacity. Capacity is the number of packages that we can process in a warehouse. And capacity can be separated or categorized into two buckets, which is under the roof capacity and on the road capacity. Under the roof capacity is the size of the warehouse, which has a practical capacity, and then we also have the warehouse associates, which is our mechanical capacity, and this is driven by the productivity of the associates on the ground. And then we have the on the road, which is the number of drivers that we require to deliver these packages on time. Then we have routing. Routing is the process of optimizing the productivity of the drivers on the road. And this is a self-learning machine that we have and that we leverage for our drivers. So basically, we give as inputs the number of minutes that we require the driver to be on the ground, and the machine gives us as outputs the number of packages that the driver can deliver and the sequence in which the packages can be delivered. Now, I call these as self-learning machines because the inputs that we give, not necessarily, the inputs that we give doesn't give us the outputs that we're necessarily looking at, right? Because there are different variables, density of the city, etc. So we cross-match this data with feedback with drivers on the ground. And so we iterate so we can get the output that we require. And last but not least, we have non-controllable variables such as weather condition, heavy rain, fog, sandstorms, which are quite popular in the GCC, and a pandemic. So all those variables that I have mentioned are data that are analyzed in dashboards, tools, or simply Excel sheets that complement each other so they can help us to drive decisions that can be cost efficient and also that can suffice customer demand. Now, as I told you before, we are going to pick up into capacity. So before the capacity, we would have a warehouse with X amount of square meters, which can process X amount of packages, and then we know how many associates we need so they can process those packages. But what happens after the pandemic? With the surge of online retail and lockdowns in place, social distancing in place, we had to make sure that we provide a safe working environment for our associates. So we had to make sure we adhere to the social distancing. So what happened overnight, basically, we had the same warehouse with the same amount of square meters, but our mechanical capacity would reduce by probably half because we couldn't have the same amount of associates on ground to process those packages. So what to do in this case, right? Our capacity overnight was reduced by half, but we still had to meet the customer demand. Now, we had to look at this problem with two lenses, the short-term lens and the long-term lens. The short-term lens would help us to manage expectations and to sustain the capacity that we had, but we had to also consider the long-term solution. So let's go into the short-term solution for now. So first of all, we had to recalculate the capacity of all our warehouses, of all our assets, and then this new capacity will serve as an input to a system called ATROPS, which is used by the supply chain team. And it would give us as an output what we call promise date. So you remember at the beginning I told you your package will be delivered within 2 days? Well, now your package will be delivered within 7 days, or probably more days, right? So this short-term solution helps us to manage expectations of the customers, help us to clear our backlog in our warehouses. But then, as I said, we had to think of a long-term solution. Now, the long-term solution must be cost-efficient, must be fast to implement, and must be a solution that can maintain the customer experience. And we had to reinstate the capacity that we lost, plus we had to increase the new demand that was coming. And probably what you think as a first guess is, let's build more Amazon delivery station. Well, it's not that easy, and it doesn't tick at least 2 of the boxes that we were looking at. So building an Amazon delivery station can take up to 1 year, and also would probably cost a couple of millions of dollars, right? So, and what happens after the pandemic is over? We would have a lot of assets that are underutilized, and as I said before, in logistics, optimizing and cost is very important. So in what we did is that we developed a last mile program called EDSP, which stands for External Delivery Service Provider. The beauty of this program is that we leverage existing warehouses of our delivery partners, and we help them with our technology to deliver the shipments. So this was cost efficient, right? Because we are optimizing warehouses across the city to deliver our packages, reinstate the capacity, plus increase the capacity. They use our technology, so that helps us to track their performance on daily basis and to ensure they optimize their operations on the ground, so we could meet the customer demand and in a good place. And this solution proved to be very efficient because we could launch an EDSP within 3 months. Now, this program is still live till date, and we also use it to expand to new areas or new cities in which the cost of building a delivery station will not be offset by the low volumes and the low density. Now, I want you to think again, because in every step of the chain, we use data. From the number of drivers that we need, from the number of rescue routes that we need, meaning how many drivers do we require in case there is an emergency. And this data gets processed and analyzed on daily basis, day -1, in fact, so we can have accurate planning, or the most accurate planning for the next day. And this is why in Amazon we have a culture of it is always day 1. So next time you order your package and it reaches to your home at a record time, remember that this is not just luck. It is the result of a lot of cross-functional data that results in action that help us navigate challenging situations. Thank you.
Thank you so much.
Short and sweet.
Thank you so much. Maybe one just quick question. I just feel bad, not really. It's really a space to interact, but we want to also keep track of our agenda. So one quick question, and then we'll go for a break.
Yeah.
Yeah, if you raise your hand for the mic, yes, please. And we have the lady here. I missed that, maybe.
Hello, thank you very much. I like the architecture, the model that you mentioned about topology, capacity, and routing, and the non-controllable items. But I wondered about the consumer behavior and cultural, input that could be also important. For example, the return rate that you might have in certain territories or areas more than others. How do you take into consideration these factors?
So this goes more into customer service. However, for logistics, what impacts us is, as you mentioned, reverse leg or reverse logistics. I think in the Middle East, there is a bit of uncertainty when it comes to using banks or credit cards. So our cash on delivery share is quite high compared to other countries, which increases our reverse leg a lot. And reverse logistics can be quite complex because it costs us money to get to your door, but also costs us money to go back and get the package when you guys don't want it. But also we need to understand what to do with the package if it's damaged, and we have to, we start categorizing things, whether it's damage and salvage or damage on salvage, and then we decide what to do with it, but that's another world of the logistics. I think MENA is quite complex, if I can compare it with other geographies because of the high rate of COD, which is cash on delivery. We have around 60% in Egypt, 40% in Saudi, and then UAE is the lowest for cash on delivery. So it might be the easiest to operate. Yeah. Yeah. Yes.
You talked about routing. You said it's a self-learning algorithm.
Yes.
And that you take feedback back from the drivers. So my question is, on average, when you do the actual routes and produce the routes, would you say drivers are required to do they stick to the routes that are given, or are they more of guidance and then you iterate in order to improve? So I'm just wondering about the percentage of time of how much they actually stick to it, or are we still at a stage where the driver on the ground knows a bit even better than the algorithm itself?
Yeah, that's a great question. So at the beginning, when we started our operations in the Middle East, because the quality of the addresses are not that good, we would rely a lot on the expertise of the drivers on the ground. So the learning curve of the drivers takes a lot of time. I mean, for confidentiality issues, I can't really show the tool, but the tool gives us how much the drivers are sticking to the route that we give them. And then we can coach them. It takes time at the beginning for the machine to understand the nuances on the ground, but once it does, the results are, in terms of productivity, are quite impressive. For example, right now, we have launched routing in one of our external delivery service providers, and they were doing 74 shipments per route. So one driver will deliver 70 shipments. And by using routing, they started delivering 140 shipments per route. So that's huge in terms of improvement. But it takes time, yeah.
Thank you so
Thank
much.
you.